Hi guys, welcome to the part 3 of the video. In part 1 and 2, which hopefully you have seen, I have demonstrated how the NodeMCU is connected with the LEDs and temperature sensor, and that is being controlled using voice commands through Mycroft AI and a custom skill. Here I'm going to show you how all these components work together under the hood. So the first component is our NodeMCU unit with all our connected components. Second thing is our Wi-Fi router. Now this Wi-Fi router and this NodeMCU is directly connected, and the NodeMCU unit is not connected with the internet. So both are basically having different set of IP addresses, which Wi-Fi router is providing. Only Mycroft AI is running on a system which is connected with the internet and which is also able to access our local LAN. So this is the network setup which I have done internally. And there is another component, very important component of our entire setup is the Thinger server. I'll tell you about Thinger server in a few minutes from now. In general, the Thinger server basically provides you a mechanism to access your devices, your IoT devices, from internet or from local LAN, because it provides you the REST APIs to control them, and you don't have to write any code to get that REST APIs coded. The server will take care of it. Thinger server will have a mechanism to securely access your resources, your IoT resources from anywhere in the world using those REST APIs. So what we are doing here in our setup is we have a Thinger server installed locally, not connected with internet, and providing us a REST API to control our red LED, green LED, and our temperature sensor. These REST APIs we are going to use in our Mycroft AI custom skill, which I named as Node Light Controller skill, and code also I have uploaded to GitHub. The link you will be getting in the description. Now what is happening here is the Node Light Controller skill is calling your Thinger server instance REST APIs to turn on and off the LEDs. So there is an API for turning on and off LED. There is an API to fetch the temperature from the temperature sensor. So we have three APIs, three URLs, three JSON payloads, and three JSON responses. So I'll show you the code and how all three, how this REST API is being used from the Node Light Controller skill. Okay, so this is how they are communicating. The Mycroft AI is calling this REST API. This REST API is calling our NodeMCU controller, and NodeMCU controller is again giving us back this details. Suppose it is the temperature, then it is giving us the temperature reading. If it is the status of the LEDs, then it is giving us the status of LEDs, and same thing is sent back to our light controller skill, and it is giving the voice output. So voice output is basically taken from here. The actual hardware input and output is happening through Thinger IO server, and this is the actual hardware which is actually doing the thing. Okay, so this was the brief stuff about the components. Now let's take the Thinger server. I'll tell you what the Thinger server is. If you'll go to thinger.io, this thinger.io is a IoT platform, and they have their own cloud services. If you want to use their cloud, then you have to pay some subscription fee, and then you can use it. But if you're running it on your own server, then it is completely free. So here is one instance which I am running on my local machine. You see it's a local IP, and this server is not accessible from the internet. It's on a separate IP address, and separately it is it's like in a sandbox in a local subnetwork. So if I log in into this thing, so now what is happening here is this local server instance, if you install it locally, you don't have to do any other configuration except you need MySQL. So once you complete the installation process of MySQL and the Thinger IO, you will be presented with this dashboard. This left hand side panel will give you all the other options where you can manage your devices. And now in Thinger IO's vocabulary, this device is basically any IoT device which you connect to it. Each IoT device can have multiple resources which it can uh, give you REST APIs for. So for example, our NodeMCU is here one device which I have created. It is online. It has multiple resources, and if you'll see view API, then I have three resources. One is our green LED, the second one is our red LED, and third one is our temperature sensor. Now before going any further on the server, I will show you the code which is flashed into NodeMCU, which is sending these resource detail to this Thinger IO server. Let's see the code here. This is the GitHub repository of this code, this custom skill, and this INO file is the file which has been, it's a sketch which I have flashed into the NodeMCU unit. So here is the first line of this code will gives you the it will point to the Thinger server instance which is running. So in my case, this is local server, so I can just put the IP address here in the Thinger server variable. Then I have to include these libraries, Thinger ESP8226 and ESP8226 Wi-Fi.h, which you can install in your Arduino IDE, which you will use to flash this code into NodeMCU unit. Then this code contains this username, device ID, and device credentials. These three things we will get from our Thinger server. So I'll go to devices, and this is my connected device. So this is my already created device. If suppose I want to create a new device, I'll go to add device. Here I will enter this device identifier. Here I will add some description, and here I will enter any key. This is like a password which you can randomly generate also. So this credential and this device ID is what you need to provide here in this code. This username is basically your login username. Here in my case it is Neo. So Neo, this device ID, and this device credential, these are the three things which our code will take, and our IP address of the Thinger server instance. Then this is fairly obvious, the SSID of the Wi-Fi and the password for your Wi-Fi. So these lines will give you your NodeMCU the proper credentials to connect to your Thinger IO server. So once it is connected with the Thinger IO, you will see this in your dashboard. Here it will say connected. Okay, so now this device is connected. So now so far only connection I have created. So when I'll create the connection with just raw NodeMCU unit without connecting any other components, no LEDs, no temperature sensor, nothing, then it will just give me the device. That's it. Now what I have to do is I have to create a resources for those devices. That means the components which are connected to my NodeMCU unit. For that, in my code, I will use the setup. I'm going to give the pin mode, like D1 and D6 is my green LED, and on this A0 my L35 analog temperature sensor is connected. So these pins I'm going to with these pins I'm going to create a resource for the Thinger server. For that, this is the keyword. First I'm going to initialize the Thinger server with this. After initializing this with this object, I'm going to create the resources. So you see these values under the double quotes. So green LED and D1 pin and this symbol. So this will create a resource with the name green LED on our Thinger server, our local Thinger server. This LED, red LED, will create a resource with the name red LED on the server, and this temperature will create a temperature resource on my Thinger LED server. I'll show you. If you see, go to View API, and View API, see this green LED, this is the name which I have given in the code. This is the red LED which I have given in the code, and this is the temperature. This is the only thing that you need to do to connect this entire resource and the device to your Thinger server. Now the real magic is this Thinger server will automatically or automagically creates a REST API with the request and with the proper URL and with the authorization key. So to now this URL you can use from any program that you want. If you want to control it from the Android, you can create an Android app and you can control your resources. If you want to create a Java code or a Python code, you can use these REST APIs and you can control your resources through it, and you don't have to write a single bit of code for that. Now here is another beautiful thing which this Thinger server is providing. This authorization key that you're seeing here is a temporary authorization key. This is just to test your API. You can create your own access tokens. One second. Sorry. See, if you'll see info, it will say that the authorization header shows in the example is only for testing purposes and it will last for only few hours. If you actually want to create the access tokens with unlimited lifespan, then we can simply generate a device token. Go to device and access tokens. We can add the token here. One second, I think I'm forgetting something. Why is it not showing? Alright, I already have created some tokens, but I'm not able to see them. Probably that is not this instance. Anyway, so here is important thing. Here you can create the token. You can give the token name. Here are the token permissions, which is a beautiful thing of this server. Now here you can create a permission. This permission you can give it for a specific resource. So this is the complete board. Now if you have 10 devices, then 10 devices. And you can select the action also. What specific action you want to take on that. Like suppose if you want to give the read-only access to the device, you can create your device token here and you can give the read-only permission. Now apart from the device permissions, when we are going to go to view APIs and you are going to see your REST clients, REST APIs, your REST API, individual REST API also has a authorization key. This is the authorization token for individual uh, REST API calls. So if your REST API calls have this authorization token, then only your REST API will work. Otherwise, it will not work. To create this particular token, you have to go back to your devices. Here you have device token list. So here I have created two keys already for temperature sensor and for LEDs. We can create any number of keys here. And why it is not coming? Because I have two resources and probably I have created it. Okay, anyway, once you click on add, you will see a window. Why it is not opening the window? Okay, so that might be the Chrome problem, I think so. Anyway, on clicking of add, here it will give you the token name, which you can give any token, and then you can select limit the resource action for this token, and you can actually select which resource. The earlier that I have shown you in token creation, that was for the devices. Now you have multiple devices and you want to give particular access to the particular device. This is API specific. I mean, this is the particular resource specific. So I have 3 resources here, and I want to create a token for the red LED, and I want to limit this token. Say tomorrow it will expire, or day after tomorrow it will expire, or it will never expire. And if I'll click OK, I'll just generate a token. I'll just give some name and I'll click OK, and here's my key. Now this device token I can use in my REST API call, and it will be an authorized call, and after 2 days or whatever expiry date I have given, this thing will expire. So all these stuff, I'll just remove this. Anyway, I don't need it. I already have 2 device tokens. So this is the functionality for Thinger.io. It will give you the detailed REST API along with the authorization tokens, which you can control the access device wise and your particular resource wise. It also has a important feature called data buckets. You can create a data bucket, and it will like suppose temperature sensor you have, so you can just collect data. You can set some time, and it will call your resource, and it will collect the data, and it will just store it. Then what you can do is you can just go to your dashboard, and if you are going to create a dashboard, you just you can add your data bucket to it, and you can view it graphically. So there are lots of features sorry, lots of features provided by this server. It will give you the live data transmission. It will show you graphically all the details. So our main purpose for using this is that first we can run it locally. In second, it will instantly give you the REST APIs, which we can use anywhere from any client, even directly from the REST client. Also, you can use it. Plus, if you want to test your APIs, it will just it like suppose the LED is on and off. So here I have the switch automatically. It will come. I will just turn it on and off, and it will just run. And here it will give you the actual query. Now I'll show you the code where we are using this. We are using basically it from the Python code. It's a Mycroft skill, so I'll show you how Mycroft skill looks like. We'll go to the code. This is basically the folder where the skill code is written. So basically, any Mycroft skill has this basic structure. It's having two folders, dialog and vocab, and it'll have Python code init.py. This is where most of the skill logic is written. And in the dialog, these dialog files are basically the words which we want Mycroft to speak. Like if suppose light is on, and after light is on, we want Mycroft to give some response, the variable responses that you have seen in the demonstration videos. Those variable responses we can write here, and these variable responses takes the variables. So if suppose we ask Mycroft to turn red light on, and the red light is on, so Mycroft will say red light is now on. So this red and the state, these two variables it will take, and it will put it into this sentence, and it will speak. So this is basically for communication to giving the output using voice. This dialog folder is containing the language specific folders. So suppose there is an output which you want in German, so you can probably create a folder en dash whatever the German language code is, and then inside that you can create the dialog files. Then the most important thing of a Mycroft skill is the vocabulary, which is in the vocabulary folder. It again has a language voice directory. So these are these VOC files, which we call vocabulary files. These vocabulary files basically contains the a pattern of what you are going to say, and if that will match to this pattern, Mycroft will connect this to your skill. I mean, to what you are going to do. This will identify what skill you want to trigger. So this is like a intent recognition thing. So I have written a few of the words which I will say, and Mycroft will connect this to my node light controller skill. So like say for example, we said turn red light on. So this red and this light it will identify, and it will connect this with my skill, and then it will execute the init-py code. This file. So now what is basically happening is, suppose I say turn the light on, turn red light on, so it will identify, the Mycroft core has the code to identify this from my voice. Once it is identified, the control will be passed to this controller class. This basically is the controller class. This will identify my intent, what I'm trying to say, and according to that intent it will call any of the methods which I have written here. So one of the method which I have written here is the which will handle the on and off of the LED, and another method is to handle the room temperature. So these two methods, uh, now which method to call, that Mycroft will decide based upon that words that I'm speaking. I mean, based upon that intent which I have created. So, say for example, now we have temperature vocabulary also. Here we have room temperature vocabulary. So, if I'll say what is the temperature of this room, so it will identify that I want to say this because I am saying this, so I want a room temperature. I don't want the weather information to be fetched and uh, provided as a voice response. It will just take this intent. It will now one more thing here is this. As I said, it might confuse you with the weather response also, and it will not go to weather and it will go to this, to my skill only. For that, we have to add some extra um, keywords to our skill. So, for example, I have added room here. So, if I'm saying room, this room file just contain one single word room. So, if I'm saying room and Mycroft identify it as room, plus in my sentence I have room also, and I have temperature also. So temperature, either temperature word or hot word. So if any of these two words, if I'm saying how hot is this room, so hot is also there and room is also there. If I'll say what is the room temperature, so room is also there and temperature is also there. So these two conditions, I'm making it mandatory for a user to speak so that Mycroft can uniquely identify the skill, and it will not call the weather skill, it will call my skill to fetch the room temperature. So to enforce these words, these vocabularies are created, and in this code, now say for temperature method, the intent which is handled is this room temp. This is the VOC file name, room temp.voc, room.voc, and temperature.voc. So here when I'm saying require and require, so that means the word specified in this VOC file and the word specified in this VOC file and the pattern specified in this VOC file. If all these three conditions are matched, then it will call this function. And the rest thing is simple Python code. Once I'll get the content in this method, I have a URL. This URL is the local Thinger server URL, which we have taken from here. This is basically for green LED. This is for our temperature. This URL, you see, user new devices, NodeMCU, temperature. This is the authorization key which we will generate from our Thinger server. Excuse me. Together with this header and this URL, we are going to call using the standard request API of Python. And now because this is room temperature, so here we don't need any we don't need to tell the Thinger IO to turn on and off anything. It is just a call. It will give us the temperature. We will just show it. In this case, we will just send it to the dialog file. See, this dialog file which we have created, room temperature is, and this is the variable temperature which we are passing. So if you'll go to room temperature is dialog file, room temperature is here, room temperature is dialog. So suppose our node MCU is returning 37 degrees. So that 37 will be fetched from the JSON response, and as this temperature variable, it will be set here, and this entire sentence Mycroft is going to speak. The room temperature is 37 degrees, or it is 37 degrees, my dear friend. So this is the basic functionality of how this entire thing's working using this Thinger server. And Thinger server is giving us the REST API. Mycroft is giving us the platform to create the custom skills, and we are creating vocabularies, we are creating dialogues to make a sort of voice interface. So with the voice interface, we are taking the input, like we are taking whether we want to on or off, whether we want to turn on a red LED or green LED. So these kind of variables which we are taking from the user, we are identifying. The Mycroft core is recognizing the voice and identifying the intent and giving control to our Python code, where we are fetching it and doing the necessary service calls. Excuse me. And making this interaction complete through the voice responses. And in voice responses also, we are able to set the variables. Like if the temperature we got from the REST API is 37 degrees, we are sending this value to our dialog file back, and Mycroft is able to use that variable and give us the complete detail, give us the complete sentence. So this was the entire structure. The code is available in my GitHub account, which I'll give you in the details section of this video. And the file which is flashed into the NodeMCU is also here. This .ino file is the file which we have flashed. You can change the credentials and you can flash it. Thinger IO server, basically you can download from thinger.io, and you can install it wherever you want. If you can install it on Raspberry Pi, on your Ubuntu server, or on your Amazon Web Service also, they have server instances. And these libraries that we are using in the NodeMCU code, here I'll show you these libraries. Thinger ESP8226 library. These libraries are also being downloaded from here, this Arduino section. So you can all glue everything together and make your custom skills work. And another good point of this NodeMCU or any other IoT device with Thinger is that you'll get the REST APIs for all your resources. You can simply use it in your skill. So this will be a kind of platform where you can right now I'm connecting NodeMCU. You can probably connect a full flash Raspberry Pi, or if your Mycroft is on Raspberry Pi, then you can use GPIO pins, and you can directly connect your things with then you won't need this Thinger server in between. But you have small IoT devices like Thinger IO, like this NodeMCU units. Then you can have multiple NodeMCU units independent of your Mycroft installation, deployed separately on separate rooms, all communicating with your Wi-Fi router and to your Thinger server, and can be controlled by your Mycroft AI using your voice commands. We can extend this NodeMCU controller with various other sensors also. We can probably put some actuators and motors and servo motors, and probably we can make moving things out of it. And we can have like we can create a skill where we can speak and a robot arm or something will move. So that kind of thing you can easily manage, and you can easily collect the IoT data, and you can also periodically you can make a skill which will give you a sort of report. If you'll ask Mycroft that, okay, hey Mycroft, how was the which day was the hottest day last week? So probably my no Finger MCU is recording your data, and you can query this data using the REST API, which is also provided by your Finger server, and you can make these kind of things possible. So that was all for this video. Thanks for watching. Thanks for being so much patience. Okay, bye.